So dear students, today we are going to start our third unit, and this third unit is overall we are going to discuss about the OSI model, one of the layer called as network layer. So in unit 2 we have discussed what are all the purpose and what are all the facilities that we can avail by using a data link layer, and in this unit we are going to discuss about the key features that is available in network layer and also the major components which plays vital role for the data communication between the sender and the receiver. So this is the overall idea about today's session. So let us begin the session now. So in network layer, one of the important concepts that we are going to discuss today is switching techniques. So switching technique in the sense, in large networks, there might be multiple paths linking sender and receiver. Information may be switched as it's traveled through various communication channels. There are typical switching techniques available for digital traffic, circuit switching, message switching, packet switching. And in this video, we are going to elaborately see these operations right now. So what is be switching first? So we all know data communication is going to happen between the sender and the receiver, and we are not going to have always a dedicated path between the sender and receiver. So the packets may transfer from one sender to one receiver via different intermediate nodes. So these things are called as switching. The sender to intermediate node and intermediate to the corresponding receiver is called as switching. And in switching we have several options. We are going to discuss the major ones: circuit switching, message switching, and packet switching in this lecture. So circuit switching. The first technique that we are going to discuss is circuit switching. It's a technique that directly connects the sender and the receiver in an unbroken path, which means it is a wired, like it's like a wired telephone link. Telephone switching equipment, for example, establish a path that connects the caller's telephone to the receiver's telephone by making a physical connection. With this type of switching, once a connection is established, a dedicated path exists between both ends until the connection is terminated. Routing decision must be made when the circuit is first established. There are no decision made after that. So from this definition we understood that before transferring the actual data, both the devices will make a handshake. Handshake in the sense they will set the dedicated path to transfer the data. Once the path is set, then the data transfer is going to happen. But once the data transfer begin to happen, there is no way to change the path during the session. So in circuit switching, the path is dedicated, and once the session is started, we cannot change the path. So the routing is as said in the decision, the routing decision must be made when the circuit is established. There are no decision made after that time. So circuit switching we are continuing here. Its network operates almost same as the telephone system works. A complete end-to-end path must exist before communication take place. Then also the computer initiating the data transfer must ask for a connection to the destination. That means the sender is asking for a connection between the sender and the destinations. Once the connection has been initiated and completed to the destination device, the destination device must acknowledge that it is ready to carry on the transfer the data. That means when the sender is ready to receive the data from the sender, it has to get acknowledged by the receiver. That's what they are going to discuss here. Then advantages and disadvantages of circuit switching. So we are going to discuss these pros and cons one by one. First we are going to see the major advantages that we are going to use in the circuit switching. The communication channel, once established, it is dedicated, and there is only less chance for the loss of data. But what is the disadvantages? When compared to the advantages, it has more disadvantages, like possibly long wait to establish a connection. Yeah, we have to make a dedicated connection between the sender and receiver. It may take its own time. No data can be transmitted during that time. More expensive than any other switching techniques, because a dedicated path is required for each connection. It is also insufficient to use communication channel, because the channels is not used when the connection systems are not using it. Yeah, once the system connection is established, other systems in the channel cannot use the particular dedicated path. So it is also a one of the major disadvantages of circuit switching. So next thing is we are going to discuss about message switching. With the message switching, there are no need to establish a dedicated path between the two stations. It's going to be vice versa of the circuit switching. When the station sends a message, the destination address is appended to the message. The message is just transmitted to the network, and it is entirely form node to node form. Each node receives the entire message and stores it entirely on the disk, and then transfer the message to the next node. This type of network is called store and forward network. So what they are going to basically do in this network is, that means this type of switching is, once the message is received, it is going to be enveloped with the destination address, and they are going to store that message and forward it to the next hop, that means next node. So that's why we are going to call it as a store and forward network. So this is the working principle of switching, message switching diagram. A wants to send the particular message to H, and it's going to we are going to see the travel path is differentiated by two colors, red color and blue color. A message switching node is typically sorry, a general purpose computer. The device needs a sufficient secondary storage capacity to store the incoming messages, which could make time delay introduced using this type of scheme due to store and forward time. And these are all the few advantages, and the major ones are channel efficiency can be greater compared to the circuit switching. Switched systems, because more devices are in the channels, traffic categories can be reduced, temporarily stored in routes, message priorities can establish due to store and forward techniques, and so on. And whereas the disadvantages, it is not compatible with interactive applications, store and forward devices example, because they have a large disk to hold potential large messages. So if we want to store a particular message, then we need that amount of memory, and it is also one of the disadvantages as per the switching concept. And the next thing is packet switching. So packet switching can be seen as a solution that tries to combine the advantages of message switching and circuit switching, and to minimize the disadvantages of both. So it is going to act as a hybrid, and it's going to be taking only the positive node from circuit switching and message switching, and leaving the disadvantages. There are two methods of packet switching: datagram and then virtual circuit. And we are seeing the working principle diagram of packet switching. In both packet switching, a message is broken into small pieces called as packets, and each packet is tagged with the appropriate source and destination address. Since packets have strictly defined a maximum length, they can be stored in a main memory instead of the disk. That means, whereas in message switching, we store the data in the disk, but we are going to split the packets into minimum small values, so that can be directly accessed by the main memory. Therefore, the access delay and cost are minimized in this packet switching. Also, transmission speed between the nodes are optimized. With current technology, packets are generally accepted onto a network on a first come, first base. If the network becomes overloaded, the packets are delayed or discarded or dropped. So how we are going to set the packet size? The packet size of the packet can vary from 180 bits of the size and the data kit or virtual circuit switch designed by Bell Labs for communication and business applications, to 1024 to 2048 bits for one pieces switch. That means packet switching switch. Also designed by Bell Labs for public data networking, to 53 bytes for ATM switching, such as Luton Technologies packet switches. So these are all some data bit size, how we have to segregate the packets. So we are going to continue with packet switching. Packet switching, the analog signal from your phone is converted into digital data stream. The series of data bits then divided into 11 tiny cluster of bits called as packets. Each packet belongs to a digital address and is going to be transferred to the receiver from the center. And we are going to combine the advantages of message switching. So we are also eliminating the cost here. Again, we all know in packet switching we have two types. One is, so as we discussed, the switching has two things. Packet switching has two concepts. One is virtual circuit switching and datagram switching. So virtual circuit switching is similarly to my circuit switching, and datagram switching is similarly to my message switching. So we are combining these things and having the advantages and omitting the disadvantages. So as we discussed, the packets is still buffered at each node and queued for output over a line. Difference between virtual and datagram approaches are, With virtual circuit, the node does not need to make a routing decision for each packet. It is made once for all packets using the virtual circuit. Whereas in datagram, we have to uh, depend upon the routing decision for each packet, and when the traffic is low, it is going to make its own path, and if it is congestion is high, it's going to take its own decision. So that's it, students. I hope you people understood what is the difference between three types of switching we have seen. One is circuit switching, second one is message switching, and third one is my packet switching. So let us have a quick wrap now before ending this session. And the quick wrap is we are going to use switching techniques for transferring the data from node to node in a network layer. While transferring the data, if I have a dedicated link between the sender and receiver, we are going to call it as a circuit switching, and it has its own advantages and disadvantages. While transferring the data between the sender and receiver without any dedicated link, and the data can be transferred as a packet through different paths, then it is called as message switching. And the combination of message switching and packet switching, sorry, message switching and circuit switching are called as my packet switching. Thank you, students. So I hope you people understand this. We will see in the next lecture.